Good morning, viewers. I am Saraswathi, working as an assistant professor in the Department of Computer Science Technology. Today, we are going to see about the topic is pattern matching in Lisp programming. Lisp is a logic programming. Pattern matching. It specifies the class of expressions in matches. The pattern contains constant and pattern variables, which indicate arbitrary elements or segments. It's a sequence of elements. The pattern contains constants and pattern variable. The variable which indicate the arbitrary elements or segments. The pattern variable matching a single element is prefixed by a single question mark, and a segment variable matching multiple elements are prefixed by two more questions. Two question mark. Pattern variable is a single question mark. Segment variable contains a multiple question mark. The pattern matching is done by using rules. The rule consists of three elements. First one is a pattern to match against. Second one is some optional extra condition. Third one is a skeleton, which tells a rewrite system and what to do with the matches. We say a rule is applicable to an expression if the rule's pattern matches the provided expression. Once the rule is applicable, we instantiate the skeleton to create an expression with the matched sub-expressions. The idea for match function to accept a pattern and a expression then produce either a dictionary of binding. The binding is to encode what pattern and segment variable match which the sub-expression or the fail symbol, it upon the success or failure, respectively. Pattern matching against an expression. There are several cases we need to consider. If we have failed, we should set the dictionary to fail, but and bail out. If the pattern is a pattern variable, then we should check the expression matches the pattern variable. This is handled by a match element helper function. If the pattern is just some constant, then well, we are nearly done. So check the expression is the same constant. If so, return the dictionary. Otherwise, we have failed and return fail instead of a dictionary. If the pattern is a segment variable, we delegate the messy work to match segment helper function. The pattern is a list, some complicated expression, which is our default case. We form a new bindings, trying to match the head of the pattern with the head of the expression. Unless new binding is a failure, we recursively match the rest of the pattern against the rest of the expressions. It's an example of a pattern matching against an expression. Non-negative factors in a square root function. Square root of x and ys is a pattern. Square root of star of question mark x and question mark y, question mark y. And then resultant pattern is a ys. And the square factor simplify. This is a extra condition. Non-negative factors xy free the variable and square root of question mark x and square root of question mark y, and this a pattern variable y yes. This is a skeleton. If the either question mark x and or question mark y match a negative factor, it's caught in the non-negative factor x and y is a free variable sub expression. This person will fail to match if we have a turned off square factor simplicity, or if either square root of x and question mark y are negative factors. Basic implementation. If the skeleton is nil, return nil. The skeleton it contains some pattern variable, question mark x, return the associated value bound to it in our dictionary. It contains the pattern contains a list. Well, we have several subcases. It looks like a double question mark x, comma a2 is a segment variable. So x is a segment variable followed by some prefix. Then we concatenate the value associated with it with the substitution of the rest of the skeleton a2 with the dictionary binding. Special macros can be handled here. For example, evaluate stuff or SP slice stuff remainder. Otherwise, the skeleton looks like E1, E2. So we just create a list formed by connections. Then substitution of E1 with the binding from the dictionary to B. The substitution of E2 with the binding recursion. In all other cases, we just return the skeleton itself. Thank you.